Hi everybody. I am going to teach you some properties of rectangles right now. So let's start with the definition of a rectangle, which you all probably know. So a rectangle is a quadrilateral, so 1, 2, 3, 4 sides, and it has 4 right angles. So let's put those right angles in here. So once we mark the right angles for a rectangle, hopefully one of the things that we see is that the opposite angles now are congruent. So 90 degrees, 90 degrees. These also 90, 90, they are congruent. And if we remember what we learned about parallelograms, we said, well, if we have a quadrilateral and the opposite angles are congruent to each other, then it's a parallelogram. So we actually have that situation here where the opposite angles are congruent. So this is a parallelogram. So once we have a rectangle, we can list all of the properties of a parallelogram. So let's go ahead and do that now. We know that the opposite sides are parallel. We also know that the opposite sides are congruent. We know that the opposite angles are congruent. And it also follows that the consecutive angles are supplementary. These add to 180. Whoop. And so do these guys and all the way around. So consecutive are supplementary. And then the last thing that we learned about parallelograms for a property is that the diagonals bisect each other. So now all of these are parallelogram properties. Here's my abbreviation for parallelogram. Feel free to use it. LL for parallel, the symbol for parallel, ogram. O-G-R-A-M, parallelogram. So all of these parallelogram properties plus the couple of new ones, like 4 right angles, which of course is the definition. And then the other new one, here's our other new one that we're going to learn for rectangles, is that the diagonals are congruent. So we didn't have that before. We had the diagonals bisecting each other, which is still true, but now they are also congruent. So let's take a look what that means. So I'm going to take this rectangle ABCD, draw on some diagonals. So if the diagonals are congruent, then we know that AC is going to be congruent to DB. So they are congruent, their measures are equal. So if we know that AC, I don't know, maybe it's equal to 12. So if AC is 12, then DB is also 12. But not only that, we also remember that the diagonals bisect each other here. So these pieces are congruent. Well, if AC is 12, then each of these would be 6. But that would also have to mean that DB is equal to 12. But remember that that is also bisected, so that's cut in half. And that would mean that each of these is 6. So when you have a rectangle, each of these small pieces of a diagonal is equal to the others. So all 4 of these pieces are the same. That may come in handy. So let's try a couple of examples of typical rectangle problems. So here we have rectangle ABCD, and they're talking about the measure of angle A. Well, definition told us that each of these angles is a right angle, 90 degrees. So if this is 90 degrees, then I know that 10x is equal to 90. And x is equal to 9. In number 2, we're talking about the measure of angle C. Well, you know what? That's also 90 because it's a rectangle and all of the angles are right. So this entire angle equals 90. X squared plus 3x plus 62 is equal to 90. X squared. There's an x squared, then I probably have to factor it. If I have to factor, then the whole thing has to be equal to 0. So I am going to subtract 90 over to the other side. I'm going to squeeze it in really tiny here so that I can kind of not use a whole line. X squared plus 3x, okay, 62 minus 90. I put it in my calculator. Minus 28 is equal to 0. All right, it's looking good. Now I'm going to have to factor. Let me set myself up for factoring. Okay. X in the beginning of each. Okay, let's remember this. I have to multiply to 28 and subtract to get 3. So here I want to find two numbers that will multiply to give me 28. And when I subtract them, I will get 3. Well, let's see. I'm thinking those numbers are going to be 4 and 7. And since I'm multiplying to get a negative 28, then one has to be positive, one has to be negative. Positive 3 when we combine, plus 7 minus 4. But again, these are the factors. One more step. Your solutions will be positive 4 and negative 7, which is great for the algebra. But we have to see if it's going to work with the application with geometry because our angles have to be positive. So we pull out our calculators. Let's turn them on. Let's plug 4 in and see if it works. You can tell I already did it. So I am going to do 4 squared. 4 squared, oh, that's 16. Plus 3 times 4, 12. Oh, I forgot my plus. Plus 12. Plus 62. 90, that guy works. Now negative 7, that's the one that I was a little worried about. Let's see what happens. Negative 7 squared. Well, that's negative 7 times negative 7, and that's a positive 49. I'm just going to type in 49. Plus, now I have my 3 times negative 7. That's negative 21 or minus 21. And plus the 62. Oops. And that is also 90. So you know what? That works also. Yay, both of these work. Good stuff. Moving on. Number 3. So, first thing we looked at was when the angles are equal to 90. Here's the other property that's kind of new about rectangles, and that's if BE is equal to 7. I'm going to put a 7 here. We want to find the measures of all of these. Now, these are diagonals and all the little pieces. Remember what we said? We said this is the same as this. So you know what? That guy is 7. And because it's a rectangle, and yes, up here we did say that they're all rectangles. ABCD is a rectangle. So now these guys are also 7s. Well, let's write it all in. ED. 7. BD, well, that's both of them together. That will be 14. And AC, well, the diagonals are congruent. That's the big new property for a rectangle. So that guy is definitely 14, so they're equal. And then it's cut in half because that's a property of parallelograms. So 7 and 7 for our last two pieces. Last guy over here. AC, which is our whole diagonal here, is 3x plus 2. Going the other way, only halfway, is x plus 3. Well, let's take a look at what happened over here. we had the entire diagonal, which was 2 7s, and this piece over here was just the 1 7. Two of these smaller pieces is equal to the whole large one. So let's say that. Let's say AC here, which is the 3x plus 2, that is equal to this one. But you know what? If that's x plus 3, then so is this, x plus 3. So there's two of them, x plus 3 and x plus 3. Let's combine some terms. 3x plus 2 is, well, it's 2x plus 6 minus 2x minus 2, and x is equal to 4. If you plugged it in, we would actually get the 7s all over again. 7, 7, plug 4 in here, and that's 12 plus 2, and that's 14. That's the whole diagonal, it's 14. Well done. Okay, so little quizzes assignment for you. Good luck with it all, and pop in if you have any questions.